Okay, in this video we're going to discuss extrema and the first derivative test. So previously we talked about how we can use the first derivative to find portions of your graph that are increasing and decreasing. Relative extrema are defined by the points at which a function changes from increasing to decreasing and vice versa. So it's the points at which the graph turns. So I'm going to say at which a function changes, but you can picture it as where the graph turns from increasing to decreasing, and vice versa. So you could be going from decreasing to increasing. So I'll draw a quick picture for you. So where we go from increasing to decreasing, this would be called your relative extrema. That would be your extrema. Actually, one point would be called extremum, but we're going to be talking about that in a minute. Also, from decreasing to increasing, that would be called also extrema. Okay, your relative maximum. The relative maximum is f of c if there exists an interval a to b. So there's an interval from a to b, and in between a and b there's going to be c. So we're going to say that contains, so that interval is going to contain c such that f of x, which is your graph, your function, is less than or equal to f of c, which means all the other points are below f of c, which makes sense. If all the other points are below, that would make f of c a maximum. And that would be for all the x's that are contained in the interval a to b. A relative minimum is going to be called f of c if there exists again an interval from a to b that again contains c such that all of the outputs f of x are greater than or equal to f of c. And that would be for all the x's in the interval a to b. So I'll draw a quick picture, and we'll use a maximum, but my picture will include some relative minimum values. Okay, so there's our graph, and we'll just do something like this. There, trying to make some room there. I don't like that the maximum looks like it's on the y-axis, so I'm just going to shift it a little bit. There. Okay. Now, both of these happen to be on the negative side of the y-axis, but that doesn't matter. Really doesn't matter. So here I have, I'm going to call that value c, that x value c, and then this output is obviously f of c, right? And then this input of c gives me an output of f of c that happens to be a relative maximum, and it just happens to be between A and, we'll say, B. It doesn't matter where A and B are, but here's A and B. So let me color code this for you in purple. So these are, in purple, those are all my parts of my graph. So those are all the outputs, right? Those are all my outputs between A and B, and they all happen to be less than f of c. That's what this means. They all happen to be less than or equal to f of c. Therefore, f of c is going to be a maximum, and it's going to be a relative maximum. The reason why it's a relative maximum is because it just happens to be a maximum in this area that we're talking about. So in this particular region, we have a relative maximum. Now, if I look at my graph as a whole, I want to point out that the graph as a whole does not have an overall maximum, and that's because this graph increases and goes up to positive infinity. So it doesn't ever reach a maximum. However, local to this region right here, let me highlight it, local to this region right here, I do have a relative maximum. Okay, and the same would be true in this region, not a relative maximum, but a relative minimum. And this would be the location of your relative minimum. However, your minimum is actually just the y value. So let's get back to business over here. If f of c is a relative extremum, that's the singular. So that's singular of extrema. If f of c is a relative extremum of f, and notice how it's giving you the y value. So this is your y value. Is a relative extremum of f, then a relative extremum is said to occur at x equals c. So where is the extremum? Your answer would be at x equals c, or sometimes, let me put sometimes. This part's really important here because you may not know how to answer the question. If it says where, then you're talking about at the x value that it occurs, or sometimes they give the entire ordered pair. Usually they'll say the location in that case though. If they say what is the extremum, then that's your f of c value. So that would be your f of c value. That's your y value. Okay. And I think, let me just draw one more picture for you. I'm just going to sketch it. Just want to be real clear. This is a relative maximum. And that's a relative minimum. If f has a relative max or min, if your graph has a relative max or min when x equals c, then c is a critical number. C is a critical number, and we talked about critical numbers already. C is a critical number of f. Either f prime of c is equal to 0, or f prime of c is undefined. Okay? So critical numbers here come from f prime of c is 0, or f prime of c is undefined. All has to do with that first derivative. Okay, let's get to it. Find all the relative extrema of the function f of x equals 2x cubed minus 3x squared minus 36x plus 14. I'm going to speed up just a little bit here. So I'm speeding up because we already know that this is a polynomial function, right? So this is a polynomial function. And this polynomial function doesn't have any any overall maximum or minimum values, because in this case the left side falls and the right side rises. But in between that falling and rising, we've got our maximums and our minimums. So our first step is going to be to find the first derivative. So for this problem, it's a polynomial function. We're going to find f prime of x. And then we're going to set f prime of x equal to 0 and solve. And that gives us critical numbers. Critical numbers. Okay, so we've got f prime of x is equal to 6x squared minus 6x minus 36. I'm going to actually move this up so I can have just a little bit more room just in case I need it. That's going to equal 6 times the quantity x squared minus x minus 6. So we'll set that equal to 0. We've got 6 and then x minus 3, x plus 2. So our critical numbers are 3 and negative 2. I'm going to make a number line. There are no undefined values. So there's no undefined values in this first derivative. If we look at the first derivative over here, there's no undefined values. You don't have any values in your denominator that cause a problem, that are restricted. So this is a polynomial function of degree 3. Its derivative is a degree 2. Degree 2 polynomials don't have any restrictions, so we're good. So now we are going to create our number line. We're going to create our intervals. And test into the first derivative for positive or negative. So negative 2 and then 3. So we're going to place a value into f prime of x that's between negative infinity and negative 2. When I do that, I'm going to be using this function in its form right here, this factored form. If I put a negative 10 in, I'm going to have a negative times a negative, which is a positive. Between negative 2 and 3, and I can even call this increasing, right? We know that this is increasing from our previous. Okay, now I'm going to put a value in between negative 2 and 3. I put a 0 in, and I get a negative times a positive. That's a negative. So we know that our function is decreasing between the x values of negative 2 and 3. And then we're going to put in a value between 3 and infinity. That's going to give me a positive times a positive, which is a positive. So that too is increasing. So what's happening is when our graph goes from increasing to decreasing, you can picture it, increasing to decreasing, that's a max, okay? So this right here, a max occurs at x equals 2. I'm sorry, negative 2. So negative 2 something is the location of our relative max. I'm going to come back to that because that's important. We're going to put that in green. Negative 2 something is the location of our relative max. Okay, let's look at the 3. where we go from decreasing just before 3 to increasing, decreasing to increasing, that's a relative min. So that relative min is going to occur at 3 comma something. That's the location of the relative min. So we're talking about on the original graph of f of x, the location of the relative max on f of x, the location of the relative min on f of x. So how would we find that corresponding y value? How would we find that f of c? Well, we're going to have to find f of negative 2, and we're going to have to find f of 3. When I put a negative 2 in, I get 2 times negative 8 minus 3 times 4 minus 36 times negative 2 plus 14. And when I put that all in, I get positive, I think, 58. So you can do the math and make sure that you get a 58 there. F of 3 would be 2 times 3 cubed, which is 27, minus 3 times 3 squared, which is 9, minus 36 times 3 plus 14. And when I put that in, that's where I get my negative 67. So 58, negative 2. That's this right here. Negative 67 comes from putting 3 in. That's our ordered pair, 3, negative 67. So it said find the relative extrema. So this is how I'm going to write my answer. I'm going to write my answer, the location of my relative min occurs, I'm going to need more room here. The location of my relative min occurs at (3, negative 67), and the min value equals negative 67. The location of the relative max occurs at negative 258, and that max value is equal to 58. Okay. So hopefully that makes some sense. Hopefully the steps 1, 2, 3, I'm just looking to make sure that the steps are all good. I think you're good to try. So go ahead and give this one a try and press pause, come back, and I will be quickly going over the work. Really going to go over the work quickly this time. Okay, so our first derivative is going to end up being 6 times x plus 1 times x minus 1. That's after you take the derivative and you factor everything out. I think it's a negative 6. Negative 6 times x plus 1, x minus 1. You set that equal to 0, and we get negative 1 and positive 1. And then we test our intervals, and we get a negative, then we get a positive, and then we get a negative. So this is decreasing to increasing, back to decreasing. So when we're going from decreasing to increasing, this is your input. X equals negative 1 is the input for a relative min. and x equals 1 is your input for a relative max. F of negative 1 is actually going to be the minimum value. So f of negative 1, when we put that in, we get a negative 3. And f of 1, we get a 5. Therefore, the location, let's do this in another color, the location of our relative min is negative 1, negative 3, and the min value is equal to negative 3. The location of the relative max is 1, 5, and that max value is equal to 5. Now that's how I would write the answer to display or to show that I know really what each part of the ordered pair means. Okay, here's another example of finding relative extrema. F of x equals x to the 4th minus x cubed. So what I like about this example is you're going to see something interesting happen. When we take our first derivative, we're going to do this the same way. It's a polynomial function. In between the left rising and the right rising, because it's a degree 4, so the left is rising, the right is rising, we're going to have some, potential terms in here. So where are those minimums happening? Where's the maximum happening? Do we have the maximum number of terms, or does this just look, maybe this just looks, degree 4 doesn't have to have all those turning points. Maybe it just looks like this, right? So actually, I think I just drew the same thing. Maybe it just looks like this. Could be. Okay, so let's look. I don't want to distort your picture in your mind right now. So you picture whatever it is, we're going to do the math. 4x cubed minus 3x squared. Well, we're going to factor that. That is going to be x squared times 4x minus 3. We're going to get x equals 0 with a multiplicity of 2. Interesting. And 3/4. Now, this is the graph of the derivative, not the graph of the original function. So when we're looking at this, and you're thinking, oh, multiplicity, I think I know what that graph looks like. That's the graph of the derivative. We're looking at the graph of this function right here. We're just using the derivative to find our critical numbers. And our critical numbers are 0, and I think that's, did I do 3/4? Yes, 3/4. So now we need to test. And of course, testing is not the most fun when you're having to deal with a fraction, but that's okay. I'm going to put a negative value into, again, see where this arrow is pointing? I love that factored form. When I put a negative into that factored form, negative 10, I'm going to get a positive, because a negative 10 times a negative 10 is a positive, times a negative minus 3 would be negative. That's going to be negative. So my graph is decreasing between negative infinity and 0. Let's see what's happening between 0 and 3/4. Let's put a 1/2 in. When I put a 1/2 in, I get a positive, but 4 times 1/2 is 2, and 2 minus 3 is negative, so that's a negative as well. So this interval, we're also decreasing. So we're decreasing all the way from negative infinity to 3/4. Let's see what happens from 3/4 to infinity. Well, that's going to be a positive times a positive, which gives us an interval that is increasing. So what's happening at x equals 0? There is no relative max or min. However, when x is 3/4, I'm going to have from decreasing to increasing, that's going to be a min. So we'll put 3/4 in. Now I'm just doing the math here because I think it's fun. We're going back to, remember, f of x right here. So when I put the 3/4 in, I'm going to have 81 over 4 to the 4th power, which is 256, minus, now I'm going to have 3 to the 3rd power, 3/4 cubed. That's going to be 27 times, now 4 cubed, right? I need one more 4 to give me a 256. So 81 minus, that is going to be 108, and that's a negative number, negative 27 over 256. So our relative min equals negative 27 over 256 when x equals 3/4. It's another way to write it. And if you know what you're talking about, then you know that, you could write this lots of different ways. The relative minimum is equal to f of 3/4. Now that's not going to be your final answer because you need to tell us what that value is. That's negative 27 over 256. If they said what's the location, now I'm just writing all over the place. The location would be 3/4, comma, negative 27 over 256. It's a fun thing, these relative maximums and minimums. Okay, find all the relative extrema of f of x equals 2x minus 3x to the 2/3. 3x to the 2/3. This right here is going to have some restrictions. This is going to have some restrictions on our derivative potentially. Something may be undefined because we know that when we take our derivative, it might cause some denominators there when we've got those rational exponents. So let's start there. F prime of x is equal to, 2 minus 2x to the negative 1/3, which is the same thing as 2 minus 2 over the cubed root of x. Well, what can x not equal? Well, x cannot equal 0. So x cannot equal 0. That is where your function, your derivative function, is undefined. Therefore, a critical number, before I go any further, a critical number is going to include 0. Now we're going to take that derivative and we're going to set it equal to 0 and we're going to solve. So when I set it equal to 0, I'm going to have 2 over the cubed root of x equals 2. That's because I put a 0 in for f prime of x and I added the fraction to both sides. When I solve for this, 2 times the cubed root of x equals 2. I divide both sides by 2. I get the cubed root of x is equal to 1. And I solve that and I get x equals 1. So that's my other critical number. Now I'm going to make my intervals negative infinity to 0 to 1 to infinity. I'm going to plug values in to my first derivative. And when I plug values into my first derivative, you don't need me to do this. You can do this. If I put a negative 8 in, I'm going to get the cubed root of negative 8 is negative 2, and that's going to give me a positive here. If you need to go slower with your arithmetic, it's absolutely fine. If I put a value from 0 to 1 in, this is where you would press pause. You were going to try this yourself. Put a value from 0 to 1 in for x. You're going to get a negative value. And then putting a value in from 1 to infinity, you're going to get a positive value. So we're going from increasing to decreasing, which our relative max equals f of 0. Decreasing to increasing, that means our relative min is equal to f of 1. So f of 0 into our original function is 0. So the relative max is equal to 0, and its location is 0, 0. The relative min is f of 1. When I put a 1 in, I get 2 minus 3, which is negative 1. So my relative min is negative 1, and its location is 1, comma, negative 1. Okay, in the next video, we're going to talk about absolute extrema. So can I find the absolute max, the absolute min on a given interval? So that's what we'll come back and talk about in the next